Welcome back, Algebra 1. We are in Lesson 62. We're going to talk about inverse operations for just a moment. We know that the opposite of multiplication is division. And we know that the opposite of addition is subtraction. It's the inverse operation, right? If we said 2 times 3 is 6, we know that we could say 6 divided by 2 would be 3. We have that information. We also know that if we were to say 2 times 2 is 4, we could say 4 divided by 2 would be 2. So these are opposite or inverse operations to one another. So we have been using exponents for a while. Let's say the exponent of 2 specifically. We know that 4 squared is the same thing as 4 times itself, which would be 16. Well, the inverse operation to the squared exponent is going to be the square root. So this is the opposite or the inverse operation of this. So if I say 16, the square root of 16, what I'm asking for is what number times itself, or what number squared would make 16. So what I'm looking for is this number here, right? We know this is the answer to this, so this is the number I'm looking for. I know that if I were to unsquare this, I would get 4. So that's what we're looking for. We're looking for what number times itself. That's what this radical symbol says. What number times itself gives me 16. So you can say this right here equals what number squared is equal to whatever's in here. Okay, what number squared equals this? Right? What number squared equals this? And in this case, what number squared equals 9 is 3, because 3 times 3 is 9. All right, we could also do 4. And the answer would be 2, because 2 times 2 is 4. You see how that works? One of the things that you can do, let me just clear the page, make it easier on you. One of the things you can do is memorize your perfect squares. So we start with 1. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. So if you can memorize everything in your multiplications table, this is going to help you whenever you have square roots. So this is something that you might want to spend some time on, memorizing your perfect square multiplication table. And that's just numbers squared. So that'd be 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. And then 12 times 12 is 144. All right, so any of these, if I were to take any of these numbers, if I were to say, oops, that was a mistake. You can erase that. If I was to say the square root of 49, the answer would be 7. Because we'd have that reference down here that 7 times 7 is 49. That's what we're looking for. If I were to ask you for the square root of, 25, the answer I'd be looking for is 5. The square root of 100 is 10. You see kind of how that works. That is how you solve a square root. And whenever you come across a square root, if you can solve it, if it's a perfect square, you need to go ahead and solve it. Most of the time in algebra, as a standard rule, we do not solve a square root that isn't a perfect square. Typically, if we have a number like this, it's not one of our perfect squares. As you can see, it's not in the list. Typically, we would leave it like this. We would not solve it. But in order for you to understand exactly what this is asking you, we are going to give you some examples and let you try to solve some with a calculator, because there's no way that you can solve this without a calculator. So let me clear this page for you. You might want to write these down on the back of your notebook or somewhere with handy reference, and you don't have to write them down like this. You could just as easily say 7 squared is equal to 49. Or you could say the square root of 49 is 7. You could write it down like that, so every time you see the square root of 49, you know what the answer is. It is not cheating to have a reference in regards to what we call math facts. You remember in elementary when you learned addition facts and subtraction facts and multiplication facts? These are square root facts. Write them down, memorize them. It's good for you to know them. All right, sometimes we want you to understand where a number is coming from. So for instance, if I wanted to do the square root of 18, I can't really solve that. I really can't. You have to have a calculator in order to solve anything that is not a perfect square. And we know that 18 is not a perfect square. So only if a problem asks you specifically to use a calculator to solve a square root, that is when you solve a square root. And this is how you would solve a square root on a calculator. You would type in, this is a scientific calculator, 18, and then you would click the square root symbol. And the square root symbol is the one that has the 2 with the x under it. This is the square root of 18. It is a non-terminating, non-repeating decimal. It is an irrational number. When we have an irrational number like this, that is why we typically do not solve for the square root of a number. That's like this. If we can solve it to a whole number, then we will. But typically we do not solve a square root because it ends up being something like this. We can't write all that down. Instead, what we have to do is round that to a specific decimal, whatever decimal we are given to round it to. So in this case, let's round it to the, let's do 5 decimal places. Okay, so we have 4242640, right? 424, and I've forgotten already. 2640. Okay, 2640, and then that was 687119. 687119. I think that's as far as we'll go. We want to go to the 5th place. So 1, 2, 3, 4. That'd be 5 right here. All right, so we look at the number to the right of it, and we ask ourselves, is this number greater than or equal to 5? No, it's not. It's 0. So we say, forget all the rest of that. This is the answer right here that we're looking for. So that would be how we would solve that. It would tell us, I need so many decimal places. That's what you're going to round it to. You're going to go through the process of rounding by going to the place you need and looking to the right of it and asking if it's greater than or equal to 5. If it is not, then you just forget all of those numbers to the right. You just cross them out and you stick with what you have. If it is equal to 5 or greater, then you change this, you add 1 to this, and you forget all the rest of these numbers as well. Okay? That's just a little quick review on rounding for you. But you could see now why we do not solve this. We just leave it the way it is, typically, unless your problem specifically asks you to solve it in round. You leave it like this because you're going to end up with an irrational number that you can't possibly calculate. It's just going to be impossible to wrap your head around. So that being said, let's do one. Let's do another one. That was example 1, by the way. let's do example 2. And example 2 says this. It says, using a calculator, determine 2 square roots determine the 2 square roots of 10. All right, I'm not writing this very well. Okay, so when we determine a square root, let's say here's our number, 16. We assume that it is positive 4. Right? We assume that. Because this is a positive number, we want this to be a positive number. But technically, if we were to get all specific, it could also be this number. Because negative times a negative also gives us a positive. So many times we forget the negative because this is a positive number. So we have to tell ourselves that we want the negative number, not the positive. So we tell ourselves to do it like this. We say, I want the negative square root of 16. So we put that negative symbol out front. So then that tells us the answer is specifically the negative version of these 2 possible answers. Okay? And as we go further into square roots, we'll start doing this. We'll start saying, I want the positive and the negative of the square root of 16. And then that'll tell us, I want both of those. And then that'll be your answer set. But until we get to that point, assume that if there's no symbol out front, that we want the positive number. And only when we ask for the negative do we get the negative number. All right, this will be sometime in the future when we start completing the square. So now we understand this next problem that we have, and it says, use a calculator to determine the 2 square roots of 10 to 6 decimal places. All right, use a calculator to determine the 2 square roots of 10 to 6 decimal places. So here's our calculator. Let me clear it. So we're going to type in 10. We're going to hit the square root symbol. All right, so we have 6 decimal places, what we're asking for. 1, 2, 3, 4, 5, 6. Okay, so now we look at this, and we look to the right, and we say, is this number greater than or equal to 5? It is. It's greater than or equal to 5. So we cross out all of this, and we add 1 to the 7. So that'll be an 8. So I'm going to write that down and do that for you. 316227766. 316227766. All right, we want the 6th decimal place. That's right here. So is this number, and then we have a bunch of numbers out behind that. Is this number greater than or equal to 5? It is. So we cross this out and we add 1 here. So now the answer is 3.162278. That's how you do that. And the 2 square roots would be this and the negative. So when it specifically asks you for the 2 square roots, it's asking for the positive and the negative number. And they're the exact same number. You just write it down again and you make it the negative version. Okay? All right, so that's how you would use a calculator to determine the square root, and this would be the positive and the negative possibilities of that square root. All right, and that was 62.2. So let's clear this, and let's move on to the 62.3. All right, using a calculator, we're going to write the squares of counting numbers 1 through 20. And we've already done 1 through 12. But let's just go ahead and do it anyway. All right, so 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, okay, 6 squared, 7 squared, 8 squared. For sure, put these in your notebook because you're going to see these numbers again, right? It is going to come up in your math. So if you have all of this written somewhere in your notebook for reference, then you're not going to have to whip out that calculator. You can just flip a page and you don't have to push any buttons. It's already done for you. All right, so there's 1 through 20. So now we can put what that is. So it's going to be 1, 4, 9, 16. And yes, Miss Tracy knows these by heart because I'm really old. And when I was in school, we didn't have calculators. We had to calculate everything using sticks and rocks and an abacus. Not really, but it's funny to think about. No, we had calculators back then too. We've had calculators for a very, very long time. 13 is 169. 196. Starting to get difficult. I don't have these completely memorized. Most of them, some I have to figure out on the fly. Like, what is this one? Oh, that's 256. And then 289. 324. All right. So there are your points of reference. Write that down in your notebook or on your back cover so that you can solve the square root of this without having to look it up in your calculator. Okay? Memorize these and you can solve your work much faster. All right, and this is actually 62.3. That's what 62.3 wanted you to do, was just do 1 through 20 squared and write out the answers. So we did that. So put that in your notebook back cover for a quick and easy reference. And listen, if your back cover gets full, move on to the back page of your notebook. All right, let's do 62.4. This says, using a calculator, determine what two consecutive integers, or between what two consecutive integers the square root of 10 lies. All right, so we know integers are whole numbers, right? So all we need to do is say square root of 10 is 3 point something, right? So we know this is greater than 3. 3 is an integer. So 3 and 4, it's between those two. That was pretty easy. So the square root of 10 is between 3 and 4 because it's a 3 point something, something, something. That was pretty straightforward. All right, now the other thing that you can do without using a calculator is this. You can actually look at your numbers that you wrote down in the previous example problem, and you can say, okay, I know that the square root of 9 is 3, and 9 is 1 less than 10. So it has to be between 3. All right, and then the next number up would be the square root of 11. We can't do the square root of 11. It's not an even number. All right, so it's not that one. It's not that consecutive integer. So what about the square root of 4? That's the next integer. So square root of 4 is going to be 16. So it has to be 10 is between 9 and 16. So it has to be between 3 and 4. Right? That's how you would do that. So 3 and 4 would be the same answer here. This is without using a calculator. This is with using a calculator. Either way, you get the same answer just by using a little bit of logic. Okay. All right, so let's talk about higher order roots. Now we know that this symbol means you're looking for what times itself gives you 16, and that would be 4. But there are going to be times when you have something that looks like this. This little number right here is called the index. And in reality, this symbol has an index as well. That index is 2. When there is not a number written here, then that index is 2, because that is the smallest root that is possible. Because if you have a 1 root, it's just the number itself. There is no multiplication going on. The smallest thing you could multiply is 2 numbers, 2 units, 1 number times another number, because you can't multiply 1 number by itself. So the smallest possibility that could go here is 2. So that is why by default, when there's nothing here, it is a square root. When you have another number written here, this is giving you what it wants. This says, how many times, what number times itself 3 times gives me 8? And the answer is 2. Because you can do a root tree here. A factor tree. I don't know why I said root tree. We know that 2 times 2 times 2 is 8, right? 1, 2, 3 identical numbers. That's what this is asking for. 3 identical numbers multiplied together gives us 8. What is that number? That number is 2. All right. See how that works? So this is what we call a higher order or an indexed root. So if I were to say, what is the 4th root of 16? That would mean what number times itself 4 times gives me 16. So we could do a factor tree and find out. First of all, we know that 4 times 4 gives me 16, but that's only 2 numbers. I need 4 numbers. Right here, this says 4 numbers. So we can take it further, and we know 2 times 2 times 2 times 2 gives me, or I should write it better than that. Write it like this. 4 times 4 gives me 16. 2 times 2 times 2 times 2 also gives me 16. That's 1, 2, 3, 4 identical factors. So the answer is 2. All right. Sometimes this is the way to solve it without a calculator. Sometimes this is faster. Sometimes it's not faster. Sometimes you do need the calculator. And if you want to do it on a calculator, here's how you solve it on a calculator, which I highly recommend. There's nothing wrong with a calculator. Y'all, I'm going to tell you, not everybody's a genius. It's okay. It's okay. Use a calculator. It's fine. All right, you see this little one right here? This little, I don't know if y'all can really see that. It looks like this. There's a little button on here. It looks like X and Y. What that is saying is type in this number, press this button, and then type in how many, what the index is, how many identical factors you're looking for, right? So this is the button on the calculator. So let's do that. Let's type in 16 unknown index, and the index is 4. We hit equal, and it tells us the answer is 2. How about that? Now, you'll see some that are built in. You've got square root is built in. Cube root is built in. A lot of times you'll see the cube root. Sometimes you may only see on your calculator square root and an index, where you can determine the index. That's fine. But in this particular calculator, I have square root and cube root already done. And if it goes higher than a cube root, I can type it in and get the answer. Okay? So again, you would type in the X first, hit the button, and then type in the little number here, the index, or the Y, and then hit equal, and it gives you the answer. All right? That's how you would solve that. All right, so let's look at an example problem. And in this example problem, we have 3, an A, B, and a C. This is 62.5. And we are asked to solve the cube root of 8, which we've already done. And we need to solve the fourth root of 81. And we're asked to solve the cube root of negative 27. All right, look at that. There's a negative sign in the root, right? That means something. So we'll pay attention to that when we get to that one. So first of all, we have the cube root of 8. All right, we've already done that, but let's go ahead and do it again. We know 2 times 2 times 2 gives us 8, right? That's 1, 2, 3, 3 identical factors. So the 3 identical factors that give us 8 is 2. So that's the answer. All right, what about here? Let's do a factor tree. Let's find out. So we know that 81 is a perfect square. We remember that because we have that reference in the back of our book. And we know that it's 9 times 9. But that's only 2 numbers. Wait a minute. 9 is a perfect square also. We know that 9 is 3 times 3. Right? So both of those are 3 times 3. 1, 2, 3, 4. 4 exact same factors for give us 81 is 3. So that equals 3. Okay? Now in this one, we have a negative 27. What are the factors of 27? Well, we know that 3 times 9 is 27. Okay, hold up. It's got to be negative. One of these has to be negative, right? And we need 3. Well, if we break down 9, we get 3 times 3 again. If all 3 of these are negative, we know that an odd number of negatives gives us a negative. 3 is an odd number. So negative 3 times negative 3 times negative 3 is going to give us negative 27. So the answer to this is negative 3. So pay attention to this. When you have an odd number and you have a negative here, a negative product, that's what that is, because this is a multiplication. These have all been multiplied together to give you this, so that's a product. If you have an odd number index and a negative product underneath your root symbol, then you're going to equal a negative factor. Okay? Just like we have here. You're going to have a negative factor. If it's not negative, then it's incorrect. And it will have points taken off for that. You have to be sure because the right answer is negative. That's the whole point of putting the negative sign in there, is to see if you catch it, to see if you can find that that is a negative number. That's like half of the problem. So if you don't put the negative sign there, I'm taking off half points because that's the whole point, is for you to catch the negative. All right, so make a note of that. When you have an odd number index and a negative product underneath the root symbol, then your answer has to be a negative factor, okay? All right, that was 62.5. If you haven't written those down, do so. You're going to see these numbers all the time. We're going to use these a lot. Let's move on to evaluating using plus or minus with these roots. So I mentioned earlier that we specify which one we want, right? Like I could say this, and that means that I want -4 over here, right? We've discussed this just a moment ago. So, for instance, the equation x squared is equal to 4, right? We know that 2 times 2 is 4, so x has to be 2. Right? That's what we automatically assume, is that it's positive. But the truth is that it could also be -2. I mean, we discussed this as well. So when we solve for a square root, we have to assume that it could be either number. And unless we specify this number, the negative number, we are, going to have to give both of them. So the way we write that, instead of having to write 2, -2, we would write x is equal to the positive or -2. Okay? So the square root of 16 without asking for a positive or a negative, if it's not asking for a negative, then it's asking for both. The answer is going to be a positive or a -4. Now you've seen this symbol on your keyboard, your algebraic keyboard within Jupyter Ed. This is what we use it for. So you're always going to give us these two possibilities. It's two different answers. It's either a +4 or a -4, and we write it like this. We put that little symbol there to give us the answer. So let's do a practice problem for this. We have, this is 62.6. We have the negative square of 2 plus -3 squared plus or minus the square root of 4. So let's evaluate that. So we have the negative square of 2, right? So the negative we know is not attached to the 2. The 2 and the square are attached. And this is just like saying this, right? This is all enclosed in the parentheses, and the 2, the square, is attached to the parentheses. So it's everything in the parentheses. So -3 times -3 is going to be a +9, right? So let's go ahead and take care of this one first. So 2 squared is 4, and we want the negative. So -4 plus 9. And the square root of 4 is 2, because 2 times 2 is 4. But it could be plus 2, or it could be -4 plus 9 minus 2. Plus or minus 2. Those are two answers that we have to solve for. So in this case, we have -4 plus 9. That's going to be 5, +5 plus 2. The answer is 7. Or we have -9 plus, or -4 plus 9. That's a +5 minus 2, which is 3. So our answers are 7 or 3. That is what we have. So when we have a plus or a minus, we have to evaluate for both the positive sign and the negative sign. So that means instead of having one equation, or one expression, we actually have two expressions here, and we have to evaluate both of them. We have to solve for both of them. All right, that's all we have for lesson 62. I will see you guys in lesson 63.